sometimes the best substitution to make isn't even visible until after we've messed around with the integrand somehow.
For example, what's the antiderivative of 1 over 1 plus cosine x dx?
What can you do?
Well, your first move might be to try the substitution u equals cosine x, in which case du is negative sine x dx, but there's no visible sine x in the integrand.
Well, since we're talking about invisible substitutions, we should try to mess around with the integrand.
Instead of doing that, let's try a different trick. Let's try to multiply 1 over 1 plus cosine x by 1 minus cosine x divided by 1 minus cosine x. This doesn't change the integrand at all because this is just 1.
This trick makes a hitherto invisible substitution visible. I'm getting ahead of myself a little bit. Let's first apply a trig identity.
So this is 1 minus cosine x in the numerator divided by, that's 1 minus cosine squared x. And then the trig identity is that 1 minus cosine squared x, well, that's sine squared x. So now I want to antidifferentiate 1 minus cosine x over sine squared x dx.
Well, even that isn't so great. Let's split it up.
Well, then I get that this is antiderivative 1 over sine squared x dx minus the antiderivative of cosine x over sine squared x dx.
Now that first integral is one that I can do.
Rewrite it as the antiderivative of cosecant squared x. And now I just have to think, do I know any function whose derivative is cosecant squared? Yes, right? Negative cotangent is an antiderivative of cosecant squared of x.
What about that other integral?
Well, I could read this as cotangent times cosecant and then just recognize the antiderivative that way. But to demonstrate the technique, I can also apply u substitution to that antidifferentiation problem. So let's let u equal sine x, and in that case du is cosine x dx, which is great because that's the numerator there. So this antidifferentiation problem becomes what? This is the antiderivative of du over u squared. And I just got to think, how do I antidifferentiate u to the negative second power? Well, that is by the power rule plus 1 over u. All right, plus c. Right? If I differentiate 1 over u, that gives me negative 1 over u squared. Okay, but I don't want my answer to be in terms of u, right? I want my answer to be in terms of x. So this is negative cotangent x plus what's 1 over u? Well, that's 1 over sine x, which if I wanted to, I could write as cosecant x plus c.
Let's put it all together.
So what I'm claiming here is that the antiderivative of 1 over 1 plus cosine x dx is negative cotangent plus cosecant, plus some constant.
If you haven't already, I hope you're getting the idea that there's some really clever things that you can try to make these substitutions work.